So here's a piggyback lesson on substitution to find the limit. So I've been saying this before this lesson. The word indeterminate is right there. That when you get a situation of 0 divided by 0, we don't say that's undefined, but instead we say indeterminate. In this case, we don't know. It might be possible or may not be possible. Because we don't know, we call it indeterminate. So when I evaluate these limits, I'm going to separate the numerator and denominator and see what I get. So first of all, what happens when I substitute in? So if I separate the numerator, x subtract 3, that's 0. How about the denominator? If I plug in 3, that's 9 plus 6, take away 15. So notice the numerator and denominator give you 0. That's an indicator that there's a hole in this function, that the limit might exist. It may not, but it might. So what we're going to do algebraically is we're going to simplify it. So to simplify this, we're going to factor. So to factor out the denominator, it's a simple trinomial. So what two numbers multiply to negative 15 and add to 2? So that's positive 5 and negative 3. So positive 5 and negative 3. Notice that these divide out. That's the whole that's dividing out. And then what's left is 1 over x plus 5. Now I do a substitution again, and I can see the answer is 1/8. Number 2, plug in negative 1. So into the numerator, if I plug in negative 1, and then simplify it. So that's clearly 0. I'm going to do the same thing with the denominator, and that is clearly 0. So this means it's indeterminate, which means up here, I'm going to write it over again, but I'm going to factor it. So the numerator, when I factor it, it's a simple trinomial, so it's negative 8 plus 1. Those are the numbers that multiply to negative 8 and add to negative 7. X plus 1, and notice what then divides out. And because this divides out, it creates a hole, which means the limit exists there at the hole. And then I can just substitute in of what's left over. So after I simplify it, plug in negative 1, and you can see that the answer is negative 9. 2. So I'm going to separate it. So numerator, plug in 2. And if you plug in 2, you get the answer 0. Plug in 2 to the denominator, and again you get the answer 0. This means it's indeterminate, which means I can factor and simplify. So factor the numerator, that is x minus 2x subtract 3. Factor the denominator, that's a difference of squares, plus 2 minus 2. And then divide out the common factor. So there's the whole, the common factor. What's left over, I'm going to do the work again and plug in. So now I can plug in. So 2 take away 3, that's negative 1. 2 plus 2, that's 4. And I have my answer for the limit, negative 1/4. Number 4. First, I'm going to make sure that it's indeterminate. So when you plug in negative 4 into the numerator, does it give you an answer of 0? I'm going to tell you it does. And then when you also do the work in the denominator, substitute in, 2x squared plus 8x. What does that give you when you plug in negative 4? And I'm going to tell you again that it's 0. That this means it's indeterminate, which means I can factor. Now, what I'm looking at in the numerator is not a trinomial, but something of a higher order. So I'm going to factor this by grouping and hope I can factor it by grouping. So when I look at the first two terms, what do they have in common? X squared. So you factor out an x squared and you have x plus 4. For the next two, I'm going to factor out a negative 1, and you're left with x plus 4. For the denominator, I'm going to factor out a common factor, which is 2x, and be left with x plus 4. And I want you to notice that there's a common factor you could divide out of each one. So I'm dividing that x plus 4 out of each one, which means I'm now left with the limit as x approaches negative 4. I'm left with x squared subtract 1, because there's 1 left over, and then 2x in the denominator. Now I'm going to plug in. So that's 16 take away 1, that's negative 8, and you have your answer. Number 5. So we're going to work at this a little bit more efficiently now. So if you plug in 6 in the numerator, you get 0. If you get 6 in the bottom, you get 0. You could probably trust me or use a calculator. So we're going to factor. So the numerator, when we factor it, it's going to be negative 6 and positive 4. The denominator, when I factor it, I'm first going to factor out a common factor. No, there's no common factor. So on the side, I'm going to factor out a more complicated trinomial. So I'm going to go 3 times 12 is 36 and negative 20. So the two numbers that multiply to 36 and that are, what? Oh, negative 18 and negative 2. So they multiply to 36 and add to negative 20. Tricky, right? So we're going to factor this by grouping. So we're going to have in the denominator, oh, and I can't forget the limit notation. That's the easiest thing to forget that's bad. Make sure you start with that limit notation. So in the denominator, I'm going to have 3x squared minus 18x minus 2x plus 12. Then I'm not going to forget the limit notation until the last step. You can let it go. Now I'm going to factor by grouping. So I still already have x minus 6 and x plus 4. In the denominator, I'm going to factor out a 3x and be left with x minus 6. I'm going to factor out a negative 2 and be left with x minus 6. So you can see the common factor here. So x minus 6's, they divide out. And then I can do a substitution. So now when I substitute in, 6 plus 4 is 10. 3 times 6 is 18 minus 2. And that's it. So you could write this as 10 over 16 or 5 over 8. So here are some algebra skills to be able to evaluate a limit. Again, negative 2. Step 1, when you plug negative 2 in and negative 2 in, we do not want to write down equals 0 over 0. We're not doing that because they're not equal to each other mathematically. But we know it's 0 over 0. It's indeterminate. That means we're going to factor to evaluate this limit. So how do you factor x cubed plus 8? This is called sum of cubes. And there's a little formula, which I forget. But you know what I do know? There's a 0 that I can use as a factor. I know that negative 2 cubed plus 8 is equal to 0. Negative 2. So because I know negative 2 is a 0, I'm going to use synthetic division. So we have 1x cubed, 0x squared, 0x's, and just 8. So to simplify this, I'm going to use synthetic division, drop down the 1, negative 2 times 1 is negative 2, add negative and a negative, that's positive 4, add, and then negative 8, no remainder. What did I just learn? I'm going to write it in limit notation. That the factor in the numerator, negative 2 as a factor, is x plus 2. And then what's left over is the rest, which is 1x squared minus 2x plus 4. In the denominator is much easier. Simple trinomial, two numbers that multiply to 20 and add to 12. So that's 10 and 2. Then I can then divide out the whole and then do a substitution. So plug negative 2 into the numerator, and you get 12. Plug negative 2 into the denominator, and you get 8. Great answer. Done. Now, in some examples, you're not factoring, but what you're using is you're rationalizing or using what's called the conjugate. So step 1 still is, what happens when I plug in 4? Well, the square root of 4 is 2, and 2 take away 2, that's 0. And 4 take away 4 is 0. So it's still indeterminate, but there's nothing to factor here. So what do I do instead is I take the part of the fraction that has a radical part, and I do what's called the conjugate. So the conjugate of the part that has the square root. So instead of root x subtract 2, the conjugate is root x plus 2. And I'm going to do that top and bottom. Root x plus 2 and root x plus 2. Now, the numerator, I can multiply out. So root x times root x is just x, and negative 2 times 2 is negative 4. This is called a difference of squares. So just first times first and last times last. Done. The denominator, I don't even want to multiply it out because I want to keep it this way to be able to simplify it. So I'm just going to keep it that way. Notice x subtract 4 divides out. Now when I plug in 4, I get my answer. So when you divide out, what's left in the numerator is 1. And then here in the denominator, what's left is the square root of 4, 2 plus 2, and that answers a quarter. So let's try that technique again. So here we have a situation. First, you plug in 9. Don't take it for granted that 0. So plug in 9, 0. Plug in 9, the square root of 36, take away 6. Definitely 0 and 0. This is indeterminate. So our technique we're going to use is we're going to use what's called the conjugate. That's the square root of 4x plus 6. The square root of 4x plus 6. Top and bottom, the conjugate. So in the denominator in this case, we're going to multiply it out. So wherever the conjugate is, then go first times first, that's 4x, and last times last, that's negative 36. And then the numerator that doesn't have that conjugates beside each other, just put them beside each other, don't simplify it. And what you're going to notice is, let's do this. Oh, what you notice here in the denominator of what's left over, that could actually be factored further so that you could simplify it. So I'm leaving the numerator as it looks, but there's some more algebra to do in the denominator. So what do they have in common? 4, so divide out a 4 and you have x minus 9. Now it's in a situation where you can divide out the x, subtract 9. Now you can do direct substitution and get your answer. So plug in 9, that's the square root of 36, 6 plus 6, and you get your answer. All right, number 9. Can you use the conjugate? So first of all, plug in 0, obviously 0. Plug in 0, square root of 1, take away 1. It's indeterminate. So I can't factor, so I'm going to do the conjugate. So look to see where the square root is. It's in the denominator. So instead of the square root of x plus 1, subtract 1, the conjugate means you add 1. So what I do to the bottom, I do to the top. So both top and bottom. I'm going to write down the limit as x approaches 0, and now I'm going to simplify it. So the denominator, square root of x times the square root of x, the square root just undoes each other. So you're just left with x plus 1. And then negative 1 times 1 is negative 1. Notice this is going to fully simplify. And then the numerator, I'm just going to put them beside each other. So one more step. I want you to notice that 1 take away 1 leaves me just with x in the denominator. That means x divides out. That means I can now plug in. So now plug in 0 and get your answer. So that's negative 3. Square root of 1 is 1 plus 1. So that's negative 3 times 2, or negative 6 is your limit there. Again, let's practice this technique using the conjugate to be able to simplify it. So I can do I can simplify it and do a direct substitution. So first step, negative 2 gives you the answer 0. Negative and a negative is the square root of 16. Take away 4, it is indeterminate. So the next step is to do what's called the conjugate. So the square root of 14 subtract x plus 4. The square root of 14 subtract x plus 4, top and bottom. So we have the limit as x approaches negative 2. And now we're going to simplify this. So the denominator, multiply first times first. That's just 14 subtract x. And then negative 4 times 4 is negative 16. The numerator, do not simplify. Just put them beside each other. If we did this correctly, this denominator is going to simplify with something in the numerator. So notice that 14 take away, did I do the signs wrong here? 14 Oh, I got it. So these are going to be opposite factors. So 14 take away 6. That's negative x minus 2. Up here you have x plus 2. And you have the square root of 14, subtract x, and then plus 4. So notice that these are exact opposites. Instead of positive x, it's negative x. Instead of positive 2, it's negative 2. So when they divide out, they leave you with the number negative 1, not positive 1, when they're exact opposites. Now you can substitute in. So plug in. That's the square root of 16 plus 4. That's 8 divided by negative 1. And that answer is just negative 8. Number 11. Again, we're going to do the conjugate. So first, actually, we're going to plug in 7. That's the square root of 9. So 3 take away 3, 7 take away 7. It is indeterminate. So we're going to do the conjugate. In this case, it's the numerator that has the square root. So the conjugate would be 3 plus the square root of 2 plus x. The denominator, the exact same thing. 3 plus the square root of 2 plus x, top and bottom. And then we're not going to forget the limit notation. The limit as x approaches 7. The numerator, 3 times 3, that's 9. And then the last term times the last term. Well, negative and plus, that's going to be negative. Do a parenthesis to know that that's going to distribute to both. 2 plus x. And then the denominator, we're just going to put them beside each other. So I want you to know that this is 9 take away 2 is 7. And then that subtract sign goes with the x. Now look carefully. This happened on the last question. That these are exact opposites. Positive 7, negative x, positive x. So they divide out, and what you're left with is negative 1. So now I can do a substitution. I got negative 1, and then when I plug in 7, that's the square root of 9. So that's 3 plus 3. So the answer is negative 1/6. All right, number 12. Last one for the lesson. So here we go. Step 1, plug in negative 3. So I want you to notice you get 15 take away 6 is 9, and the square root of 9 is 3. And then 3 take away 3 is 0. And the bottom is 0. This is indeterminate. So we're going to do the conjugate to simplify this. So that is the square root of 2x plus 15, subtract x. The square root of 2x plus 15, subtract x, top and bottom. So the limit notation, the limit as x approaches negative 3. And now some simplifying. So first times first gives me 2x plus 15. Last times last is negative x. And then we're going to put these beside each other and not simplify them. 2x take away x. Oh, sorry, x times x, that's negative x squared. Let's make sure I do the algebra correctly. Now, the numerator, I have to do some work on. I can't factor this if the quadratic term is negative. So what I'm going to do is factor out the negative 1 to make it positive, but that makes that negative 2x and this negative 15. But by doing that, I can now factor it. So we have the limit as x approaches negative 3. Now I can factor this. This is now a simple trinomial. So that's x subtract 5 and x plus 3. The denominator, x plus 3, and the square root of 2x plus 15 take away x. Then when I look at it, now the x plus 3 divides out. Now I can plug in negative 3. No more limit notation because now you can plug in. So we have negative 3 subtract 5. In the denominator, we have 9, right? Negative 3 makes negative 6 plus 15, so that's the square root of 9. And then a negative and a negative means plus 3. So if I simplify this all, I would get positive 8. This is negative 8, but the other negative makes it positive over 6, or 4/3. And that's it. So a little bit more challenging, with the algebra, but when we do it together, we get stronger. Can you evaluate a limit that is indeterminate? Do you know what indeterminate means? And can you use algebra to simplify the function and be able to do a substitution at the end? So, Mr. G Math over and out. I'm proud of you that you're doing your work, and until next time.